Intersection of graphs. Objective. By this lesson, you should be able to solve an equation with a quadratic when the quadratic intersects a graph of a linear function or a graph of a quadratic function. So when a quadratic intersects a linear function, you have three options. They could cut it twice, so you have two intersections. They could cut one time, you have one intersection, or they could cut no times, you have no intersections. And if you remember from the discriminant, this is the same thing as saying the discriminant is less than 0, the discriminant equals 0, and the discriminant is greater than 0. It's the same idea. You have two solutions, one real solution, or no solutions. So that's going to come up later. If the line touches a curve, we say that is tangent. So this is a tangent, right? If it hits it at one spot, let's call that a tangent line. So let's do our first example. Find the coordinates of the point of intersection of the graphs with the given equations this and this. So how do we set this? Well, we want to find where they intersect, so we're just going to set them equal to each other. So we're going to substitute this in for there. So we're going to get x minus 3 equals x squared minus 8x minus 18. And lots of ways to solve this. Well, step 1 is set equal to 0, first of all. So we get minus x plus 3 minus x plus 3. 0 equals x squared minus 2x minus 15. Then we can solve this by graphing or quadratic form if we choose. I need two things to multiply to get negative 15, but add to get negative 2. It looks like it should be negative 5 and positive 3. So again, there's no x in front, so I'm just gonna solve factor straight ahead. You get this, and then since we want to solve, we're gonna split and solve. I'm gonna get x equals 5 and negative 3. That's a 3. So there we go. All right. So again, basically just send them with each other, set equal to 0 and factor, because that's the way you solve any quadratic, right? You always solve a quadratic by setting equal to 0 and either factor or use a quadratic formula. Next problem. In this next example, we're going to solve two quadratics equal to each other this time. Now, step 1, just like before, we're going to set them equal to each other. So we get x squared plus 5x plus 6 equals 2x squared plus 2x minus 4. I like to keep my x squared positive, so we're going to move everything over there. So let's subtract x squared minus 5x and minus 6 from both sides. So I get 0 equals x squared minus 3x minus 10. And again, we can solve the same we want. This is another one we could easily factor. The two things that multiply get negative 10, but add to get negative 3, or negative 5 and positive 2. So we're going to get x minus 5, x plus 2. Split and solve. X equals 5 and negative 2. So that's where they equal each other. Next, I want us to graph these two curves on a set of axes. Now we just need to sketch these. So I guess we'll find the y-intercept, the axis symmetry for each. Let's do y equals x squared plus 5x plus 6. X equals negative b over 2a, which in this case would be negative 5 over 2 times 1, which is negative 5 halves. I don't know why they made it ugly for. Let's find the y in the vertex. So we're just going to plug that in. Plus 6. Don't worry, I did the work for you earlier. Is negative 1/4. So I have negative 5 halves and negative 1/4. I don't know why they go like that for. But whatever. Next one, same idea. We want to sketch it. So you normally use ways to find the vertex because it doesn't factor either. So I don't know why they hate us. So negative 2 over 2 times 2. So at negative 1/2. If you plug it in, again, I did the work earlier, I just plugged it in. I get negative 4/5. So there's my vertex for each one. Again, don't know why they decided to make the value so ugly. Let me erase this because I do need a graph. I want to show you how a graph looks. Okay, so let's do purple first. So my vertex is negative 5 and negative 1/4. So negative 5 and negative 1/4, so around there. My y-intercept is a 6, right? If I plug in 0, I get 6. So look kind of like this. Again, it's just a sketch. And then my other graph, oops, sorry. The vertex is negative 1/2 and negative 4/5. 4.5. And then my y-intercept on that one, if you plug in 0 on that one, you get -4. So it's kind of like that. Again, just kind of a sketch. And if I actually would extend this, if you remember our answer here before I erased it, it was -2 and 5. So that's where they intersected at -2 and 5. The next question, you can kind of see on my writing. Hence solve where x squared plus 5x plus 6 is greater than 2x squared plus 2x minus 4. So x squared plus 5x is my purple graph. The other one is my blue graph. You want to know where the purple graph is above the blue graph? Well, right here, right? So on this side, the blue graph's on top, the blue graph. In the middle here, the purple graph's above the blue graph. You can tell right here, right? If you pick any point, like -1, purple's on top, blue's on bottom. So this middle part here is where it's true. Only part of that I really care about is the x values, though. That's from -2 to 5-ish. So from -2 to 5 is where the purple graph is above the blue graph. And that's the answer to that one. So next one, y equals 2x plus k is a tangent to the graph of this. Find k. So the key here is the fact that it's a tangent to the graph. So if you remember what that is, I'm going to draw a little sketch. We have a parabola. That's this graph. And then this guy's a tangent to it. That means it hits it at one spot. So it looks like this. Remember what I said earlier. What does that mean if it's a tangent to the graph? That means it has one solution. And anytime IB talks about number of solutions, you're talking about the discriminant. And remember, one solution is when the discriminant equals 0. So this comes up a lot in IB. They'll be like, oh, this has one solution, or it has two solutions, or a double root. They're talking about the discriminant, and you got to know those rules. So they're saying the solution here is equal to 0. So how do I find the solution? Well, you set these equal to each other. 2x plus k equals 2x squared minus 3x plus 4. And then we're going to try to solve it. Set equal to 0. So we're going to subtract 2x from both sides. Subtract k from both sides. Now k just gets lumped over here, right? You can't redo anything, just leave it on the side. So I get 0 equals 2x squared minus 5x plus 4 minus k. So now I can solve this. Now here's the key though, right? It's a quadratic. I don't really need to solve it for x or k. What I'm trying to do is, like, I know I had that these two they intersect one time, so they have one solution. The discriminant equals 0. So what's my discriminant? B squared minus 4ac. And then since it has one solution, I know it equals 0. And that's how we're going to solve this. Because the discriminant doesn't need x and y. All I need is the coefficients. So my a is 2. My b is -5. And my c is a constant term, a thing without an x. That's all of this. So we just gotta plug this in and solve that equation. So we get -5 squared minus 4 times a, which is 2, times c, which is 4 minus k. So that equals 0. Again, it's equal to 0 because that's one solution. And we just gotta solve this. This is 25 minus, let's see. Let's distribute this first. -4 times 8 minus k equals 0. Distribute the negative. So 25 minus 32 plus 4k equals 0. That's this -7 plus 4k equals 0. Add the 7 over. 4k equals 7. Divide by 4. K equals 7/4. And that's the answer. So remember, what does that mean? That means when k equals 7/4, that this line and this line hit each other at one spot. Since they hit each other at one spot, they're tangent to each other, we call that. And we know that the discriminant equals 0 because there's only one solution to this thing. If they hit each other at two spots, the discriminant would be greater than 0. If they didn't cross each other at all, the discriminant would be less than 0. That's how you solve it.